Greetings again, Calc 3 students. This video is for section 15.2, and it corresponds to, from our book, homework number 31, but number 11 from the 15.1/15.2 online homework section. So we have this volume of solid enclosed by this three-dimensional curve, parabola, z equals 4 plus x squared plus the quantity y minus 2 squared. And the planes, z equals 1, x equals -3, x equals 3, y equals 0, and y equals 4. So the first thing I want to do, because I'm given two pieces of information about z, I have the first one, which is z equals 4 plus x squared plus y minus 2 quantity squared. That's part of the enclosure. And I also have the situation as equals 1. That's another part of the enclosure. So I'm not very good at drawing three-dimensional things, but I'm going to sort of do some sort of sketching. So this is my x, and this is my y, and this is my z. So I notice that the coefficients here are both positive, so I'm pretty confident that the parabola is going to open up in the z direction, I guess you could say. And so then I pick, well, if I look at the origin where x is equal to 0 and y is equal to 0, so this would be 0 and this would be 0, I'd have 4 plus -2 squared, which is 4. I'd have 8. So somewhere up here is 8. And so I'm going to have some sort of shape that's going up like this from 8. Now I'm not drawing it in 3 dimensions very well, but this is sort of a sketch. I'm trying to figure out what my region sort of looks like. And I'm also have the z equals 1, so that's down here somewhere. This is 1, and then this is going to just be a plane, right? Z equals 1. And so my region that we're talking about is this space that lies below the z equals 4 plus x squared plus y minus 2 squared. Below that, but above the z equals 1, so it's in there someplace. But then on top of that, we're given a region, right? We're given these planes that it's also bounded by. So in other words, it's bounded in 3D by x equals -3, so like this direction, and the positive and negative and positive 3, and then in this direction, in the y, to 0 to 4, right? So like this 0 and this 4, okay? So I'm going to sketch out that region part on its own, those actual x and y parts, so I can get a better picture. So this is my region sketch with just the xy. So effectively what I'm doing now is I'm sketching what this 2D plane is now this part, that plane, right? That's here, that's what I'm sketching. So let me label this x and y. And so we're going to go from -3, because we're told x is equal to -3. So this is x is equal to -3, and +3, so this is x is equal to +3. And y is equal to 0, so this is y equals 0, and y equals 4, so this is y equals 4. So that is my picture of the xy plane in its region. I'm calling that fancy R for the region. So then my region R is equal to the x and y's such that x lies between -3 and 3, and y lies between 0 and 4. So that's my region. So I need to integrate the stuff that's below this 2D curve and above that curve. So how do I do that? Bounded on that region, so I'm going to integrate. I'm going to do x first, so -3 to 3, and y second from 0 to 4. And this is going to be z, the function of x and y, in dx dy. When I say I'm going to do x first, what I mean by that is I'm going to put that on the inside so that I'm integrating x first and then y second. I could choose it to do the other way around if I wanted to. And then minus the same bound, 0 to 4, negative 3 to 3, but then z equals 1. So 1 dx dy. So once again, if I look at my 3D picture, this sort of crude sketch, is I am calculating the volume underneath this. So I'm calculating all of it down to the xy plane. And then I'm subtracting away, with this minus sign, the volume that's here down to the xy plane. And what I'm left with, of course, is that blue part. I'm left with all of this once I do that. So take the whole thing, subtract away the bottom.